Hi friends, welcome back to Civil World YouTube channel. Dear friends, in this video tutorial I am Sambat showing you here very important topic for today, how to find the depth of the beam by thumb rolls. Let's get started. Remember, for more videos you must like this video and subscribe this channel for getting notification for new update civil engineering videos. So don't forget to like and subscribe this channel. So the important topic is today how to find the depth of the beam by thumb rules. In the early stage of the project, we are often asked how large structural elements will be before we have had a chance to perform the necessary computations. We have found the following rules of thumb to be used in estimating an approximate depth of the structural member as well as the reviewing the responsibleness of design. It is important to note, however, the depth of the member is influenced not only by the span but by such variables as spacing, loads, supporting condition, deflection, and clearance requirements as well. The final member design should be based on computations performed by licensed structural engineer in ACI 318 14th code. Depth of the beam hinges equal to length of the beam feet. For example, if the length of the beam is 12 feet, then depth of the beam should be 12 inches. I am showing you some assumption. First category is concrete. Hollow core floor slab. Structural depth is L by 30 to L by 40. L is the length of the floor slab. Hollow core roof slab. Structural depth is L by 40 to L by 50. Pre-stressed floor tie. Structural depth is L by 25 to L by 35. Pre-stressed roof tie. Structural depth is L by 35 to L by 40. Pre-stressed beam. Structural depth is L by 10 to L by 20. Post-tension beam. Structural depth is L by 21. Post-tension girder. Structural depth is L by 15. Post-tension joist. Structural depth is L by 36. Post-tension two-way slab. Structural depth is L by 40. Two-way slab. Structural depth is slab perimeter by 180. Flat slab or drop panels. Structural depth is L by 33. Stair slab. Structural depth is L by 26. One-way slab for simply supported condition. Structural depth is 1 by 20. One-way slab, one end continuous. Structural depth is L by 24. One-way slab, both end continuous. Structural depth is L by 28. One-way slab cantilever. Structural depth is L by 10. Beam or joist simply supported. Structural depth is L by 16. Beam or joist one end continuous. Structural depth is L by 18.5. Beam or joist both end continuous. Structural depth is L by 21. Beam or joist cantilever. Structural depth is L by 8. Girder. Structural depth is L by 11. Tilt up floor slab. Structural depth is 5 inches minimum. Tilt up wall panels. Structural depth is H by 48. Column structural depth is H by 14. First floor column structural depth is H by 10. Second category is masonry. Wall nominal reinforcement. Structural depth is H by 20. Wall heavy reinforcement. Structural depth is H by 13. Third category is steel. Floor beam or joist. Structural depth is L by 20. Floor beam, vibrating masonry or drag support. Structural depth is L by 16. Composite floor beam. Structural depth is L by 22. Roof beam or joist. Structural depth is L by 24. Joist girder. Structural depth is L by 12. Truss. Structural depth is L by 12. Space frame. Structural depth is L by 12 to L by 20. Its structural depth is L by 16. Fourth category is wood. Nominal joist. Structural depth is L by 24. Nominal scissor truss. Structural depth is 3 is 12 different between top and bottom chord or bottom chord pitch half of the top chord pitch. Nominal flat truss. Structural depth is L by 14. Timber bowstring truss. structural depth is L by 6 to L by 8. Timber global truss, structural depth is L by 6 minimum. Timber flat truss, structural depth is L by 8 to L by 10.